Hi friends, let's have a look at problem 2482, difference between ones and zeros in row and column. So this problem actually is very straightforward. So our purpose is to explain how to use dictionary and the zip built-in function. So here we are given an m by n binary matrix called grid. So in each row, they have some zeros and ones, similarly for a column. So we want to find a difference matrix. So the different matrix is defined like this. So the generic element ij is defined by the number of ones in the ith row plus the number of ones in the jth column, then minus the number of zeros in ith row and number of zeros in jth column, right? So basically, in order to get this one, we need to count how many ones in each row and how many ones in each column. Similarly, you can count how many zeros in each row and how many zeros in each column. So let's carry out this program. So here, let me give some annotation here. So here we are going to use dictionary and zip function, built-in function. So here, basically, first I'm going to get the number of rows and number of columns. So this is nothing but let's create 0, right? And then I'm going to count the number of ones in each row and the number of ones in each column. So I'm going to use row sums. So this will give you the number of ones, right? So let's use collections, default dictionary. I'm going to map everything lambda to be 0 first. So similarly, row sums. So collections default dict lambda also 0. So now let's carry out. First, I'm going to get this one, the row sums or the number of ones in each row. So for I row in enumerate grid. So the row sums, the ith row is going to have sum, that is sum row, right? Notice that there are n elements in each row, right? So this means in ith row, the number of zeros is nothing but n minus this row sums I, right? So this is the one part. So now I want to get the number of columns. So what I'm going to do is to use the zip function to transpose this matrix. So what we are going to do is this. Let me first write down for G column in enumerate. So I'm going to use zip star grid, right? So this corresponds if you pass value to a function. Let's see, you have a function, all right? So you have this one. You have passed. You have a list. Let's see, or iterable. Let's see, iterable. Let's call it array. So that is 1, 2, 1, 2, 3. Then you pass this like this. So this is meaning that we are going to do this. Array 0, array 1, and array 2, right? So in this example, it corresponds to f 1, 2, 3. So, but here, if you do this, zip star grid. So here, the grid is like this. The grid is given here, right? So now, if I pass zip star grid, right? So then what we get, zip has a function to match iterables. So, but here we use star. It means we pass each of those one as one iterable. So it's going to pass like this, passing through 3 of those things. Then, due to the functionality of zip, you are going to get an iterator, right? So what the iterator basically is this. So you get the first element in the first one, first element in the second one, and first element in third one. So you're going to get 0, 1, 0. And then you get the second element of the resulted iterable will be the second elements corresponding to each of the input. And it will be 1, 0, and 0. And the third one is going to be 1, 1, and 1, right? But if you have something that is longer, say, that's still fun, because the default behavior of this zip is going to stop at the shortest one, because the shortest one is 3 in this if we add more. So, but here we have a very neat input. They're all equal. So this one, if you look at this one, so if you change them to be a list, actually, so this is nothing but the transpose of this matrix. And then you look at each row, actually it corresponds to columns of the original matrix, right? That's what we do, G and column. And then this corresponds to compute the transpose of the original matrix. So now, because you use this for loop, it's going to retrieve the jth row of this zip object, right? It's corresponding to the jth column in the original matrix. So what we're going to do is column sum G equals sum of the column. You see, actually, it's symmetric with this one. And also, you can notice that, right? So in jth column, the number of zeros, because in each column, the number of elements is n, right? Total element. So minus the number of ones, that is column sums and G. So you're going to get a number of zeros, right? So once we have these two pieces of information, so getting the result is a piece of cake. So what we want to do, so we know the result matrix is going to be an n by m matrix, right? M by n matrix. So we're going to have this one. Let me just fill the values. So for I in range m, for G in range n, right? So now let's do some analysis. Maybe do it here. So for what we want to get, actually, is this one. Let me copy here. So the number ones in row I, that is nothing but row sum at I, right? So then minus the number of zeros at row I. Actually, if you change this one, let's put it here, right? Then I'm going to delete this one. So we actually can regroup these two. And then plus the number of ones in just column minus the number of zeros. So then the number of zeros is nothing but n minus row sum number ones, right? That's the first term. The second term, number of ones in column G, so it will be column sums at index G. The minus the number of zeros, so that is m minus the column sums at G, right? So then you do further computations. So you see here this one and this one twice, right? This one and this one negative is twice. So basically it's twice times the row sums I and plus column sums G, then minus m plus n. But m plus n in some sense constant, right? So what we want to do actually is to set this one, right? So basically the result at ig equals this term. So now we can do the return. So that's about it. So now let's do a run. Yeah, it passes the first two test cases. Now let's look at the generic case. Yeah, it passes all the cases. So here again, I feel it's a little bit similar to problem, I guess. So you can see problem 2661, similar, but here also we used dictionaries like row sums and column sums to get the information we needed in order to get the result. So I guess with that said, that's basically about it for the current video. Thank you for watching.